In late 2022, the James Webb Space Telescope locked its mirrors onto Saturn's largest moon, and the image that arrived in Baltimore made a room full of scientists go completely silent. NASA called it stunning. The people who actually read the data did not use that word, because what Webb caught wasn't a portrait. It was a discrepancy. Bright clouds sitting in the wrong latitude for that season. Haze layers thicker and higher than any Cassini-era model ever predicted. A methane signal running warmer and faster than every planning document assumed. And a first-ever detection of a molecular fragment that had absolutely no business being that easy to see. Ask yourself something honest right now. How much of what you think you know about Titan came from actual data? And how much came from the beautiful stills NASA chose to release to the public? Because those two things are not the same. In this video, we'll walk through exactly what Webb recorded, what it truly implies, and why the scientists who understand it best have gone noticeably quieter in public than they were just 3 years ago. Here is the thesis, stated up front. Webb didn't just photograph Titan. It caught the moon behaving in ways the models did not predict. And these anomalies are not decorative. They are structural. They touch the chemistry, the climate, and every mission plan currently on the books, including one mission worth $3.35 billion. 3 signals stacked up fast. Mid-latitude tropospheric clouds appeared over Kraken Mare in November 2022, drifting precisely where seasonal models said clouds should not exist. The stratospheric haze read brighter and higher than the entire Cassini baseline. And Webb detected the methyl radical CH3 for the very first time. A fingerprint of active photochemistry running at rates the standard models simply did not anticipate. Any one of those alone is fascinating. All 3 on the same target in a single campaign? That is a pattern. And patterns like that don't stay academic. They rewrite the atmospheric models. The atmospheric models feed the mission designs. And every mission design, including Dragonfly, the nuclear-powered rotorcraft NASA is building right now, was sized against a version of Titan that Webb is quietly editing in real time. What Webb saw is not the problem. What Webb saw implies. That is the problem. For 20 years, the public image of Titan was built on one mission and one probe. Cassini arrived at Saturn in 2004. The Huygens lander descended through Titan's thick atmosphere in January 2005 and transmitted from the surface for roughly 2 hours before its batteries died. Cassini itself kept flying past Titan until 2017, when it was deliberately plunged into Saturn to protect the moon from contamination. 13 years of data, hundreds of close passes, one landing that lasted less than a feature film. That is the entire foundation of everything you think you know about Titan. It is a magnificent foundation. It is not a complete one. The narrative that emerged, methane lakes, methane rain, possible prebiotic chemistry, a place where life could plausibly begin, was not wrong. It was partial. Cassini observed fractions of one hemisphere clearly, across roughly 1/3 of a Titan year, at the wavelengths its instruments were specifically designed for. Its cameras had to punch through a permanent orange haze. Its radar mapped only the narrow strips it flew directly over. Everything else was extrapolation. Careful, professional, publishable extrapolation. But extrapolation all the same. And Cassini itself flagged the anomalies. Late in the mission, radar caught features in Ligeia Mare that scientists called magic islands. Bright patches that appeared, vanished, and reappeared in completely different configurations. Nobody has fully explained them. Waves? Bubbles of nitrogen escaping from solution? Floating solids? Every candidate is plausible. None is confirmed. The seasonal cloud observations drifted from what the models predicted. The upper atmosphere reacted to solar activity in ways theorists were still fiercely debating when the mission ended. Let that sink in for a moment. These mysteries touch the chemistry, the climate, and every mission plan currently on the books, including one mission worth $3.35 billion. Those cracks were already there. They just never made the press releases. Then Cassini burned up. For 5 years, Titan was studied almost entirely by ground-based telescopes and archived data. The models froze. Dragonfly's design work moved forward on that frozen picture. Then Webb turned towards Saturn. A different instrument, a different vantage point, different questions now answerable. And the story it's telling is not the sequel anyone wrote. It is closer to a correction. Quiet, technical, and devastating in its own slow, relentless way. Titan's atmosphere is roughly 95% nitrogen and 5% methane, with traces of hydrocarbons produced by sunlight tearing those simpler molecules apart. Surface pressure sits at about 1.45 times Earth's, meaning if you stood on Titan without a suit, the air pressure would feel like standing 4 meters underwater. Surface temperature averages 94 Kelvin, minus 179 Celsius, minus 290 Fahrenheit. Now translate that. Titan is the only other world where liquid falls from the sky, pools on the ground, and evaporates back into clouds. There is a full hydrological cycle. It just isn't made of water. It's made of methane and ethane, the exact same molecules we burn in rockets and stoves. Rain, rivers, and seas made of rocket fuel, under an orange sky, in a cold that would kill you within minutes. Standing on the surface, you wouldn't need a pressure suit to keep from exploding the way you would in a vacuum. You'd need one to keep from freezing solid while breathing what is essentially natural gas weather. You would suffocate slowly. In weather no engineer has ever fully designed against. That is the baseline. That is the friendly, well-understood version. Webb's contribution was to examine that baseline with instruments. NIRCam, NIRSpec, and later MARY, capable of measuring specific molecules and temperature profiles that Cassini simply could not. What Webb found in November 2022, and again in July 2023, was, in polite scientific language, consistent with active tropospheric weather. In plainer language, the sky was doing things the models had never scheduled for. Here is the part that should genuinely disturb you. Methane in Titan's atmosphere is not stable. Even the faint sunlight Titan receives, roughly 1% of Earth's, tears methane molecules apart. Over timescales of about 30 million years, that process should have destroyed every last trace of Titan's atmospheric methane. There should be none left, but there is. Roughly 5% of the atmosphere, steadily, persistently, which means something is replenishing it, and nobody has confirmed what. The candidates: cryovolcanism, slow outgassing, a hidden subsurface methane ocean, are all deeply uncomfortable, because each one implies that Titan is far more geologically alive than anything we have directly observed. What we see on the surface is just a thin skin concealing processes we haven't even begun to understand. Webb's data narrowed the possibilities and pushed the answers towards something far more active and alarming. The mystery didn't get solved. It got deeper. The detection of the methyl radical in 2023 was a scientific first. NASA called it an important step. That description is technically accurate and profoundly incomplete. CH3 is a fragment. It's what happens when sunlight shatters a methane molecule and knocks a hydrogen atom loose. It's extremely short-lived, chemically hungry, and almost never observed directly. It exists only for a split second, between being created and reacting with something else. Detecting it in Titan's atmosphere means Webb caught photochemistry in progress, not the products, the active reaction itself. The polite reading? This confirms the photochemical chain is running as expected. The harder reading? The intermediate showed up at abundances and altitudes that standard models did not cleanly predict, which means the entire chemical machine is running at rates that force those models to be completely revised. That may sound like a technical detail. It is not. Titan's haze is produced by that very photochemistry. Sunlight breaks methane, fragments recombine, molecules condense into aerosol particles. Those particles form the layers Webb imaged. If the chemistry runs faster than the models say, the haze thickens, the surface becomes harder to see from orbit, and every optical instrument in the mission plan degrades faster than anyone planned for. Here is where this stops being academic. Dragonfly's instrument suite includes cameras. Its navigation depends on cameras. Its ability to select landing sites depends on seeing through that atmosphere. Every single one of those capabilities was budgeted against a haze density derived from Cassini-era models. If Webb implies the haze is thicker than assumed, the entire optical performance envelope has to be revisited before the design freeze. A design freeze happening right now, before the 2028 launch. Not in a decade, now. Cassini's models were revised repeatedly during and after its mission. Every revision made Titan more complicated. Webb is continuing that pattern. When a target consistently produces surprises across successive instrument generations, the correct scientific conclusion is not that we're almost there. It's that the phenomenon is far more complex than any model can capture. And when that phenomenon is the atmospheric chemistry of a moon we're about to fly an aircraft through, that complexity isn't just a paper, it's a risk. There's a mental shortcut almost everyone uses when thinking about Titan. Earth with different chemistry. Cold Earth. Weird Earth. But that shortcut breaks the physics entirely. Titan's year is 29, 5 Earth years long. One season lasts roughly 7.5 Earth years. A summer on Titan isn't a warm few months. It's nearly a decade of one slowly shifting configuration of sunlight. Gravity is about 14% of Earth's. roughly 1/7. Sunlight at the surface is about 1% of what Earth receives. Even at Titan's noon, you'd be standing in what your eyes would register as deep twilight. You could not read a book by the ambient light without help. Now combine those numbers. Air pressure 45% higher than Earth's. Gravity 1/7. Sunlight at just 1%. That combination is not a variant of Earth weather. This is a categorically different world entirely. A methane raindrop on Titan is larger than any water raindrop on Earth, roughly the size of a small grape. It falls slower, drifting gently downward. It lands softer, hauntingly beautiful in its physics. And yet, it is a rain cycle that operates on decade-long timescales, under a sun so faint it barely qualifies as daylight. In that atmosphere, winds do things Earth-scale winds never could. Because the air is denser, even a modest breeze carries far more momentum than the same speed would on Earth. Those winds sculpt massive dune fields. Cassini photographed them, sprawling across a significant fraction of Titan's equatorial regions, built under rules no Earth engineer has ever had to design against. The dunes stretch hundreds of kilometers. They are made of hydrocarbon grains that behave nothing like sand, and the winds that built them have never once been flown through by any machine. Assuming Earth-like intuition is exactly how missions die. The Mars Climate Orbiter in 1999 disintegrated because one team used metric and another used imperial. That was not a Mars problem. It was a scaling assumption problem. Titan invites that exact same class of error, at solar system distances, with almost no margin to recover. The point is not that Titan is Earth-like. The point is that people keep saying it is, then designing against that assumption, then acting surprised. Similar chemistry, completely different rules. Now bring a spacecraft into that environment. Now bring a rotorcraft. Now bring a human. Titan is frequently called the most habitable moon in the outer solar system. Read that again carefully. Most habitable is not the same as habitable. It is a comparison against places like Europa's crushing ice, Enceladus's frozen shell, and Io's lethal radiation bath. Being the least hostile member of that group is not a compliment. It is a technicality. Minus 179 degrees Celsius is not merely very cold. It is a cold at which materials stop behaving the way engineers expect. Steel becomes as brittle as glass. Standard lithium batteries stall completely. Rubber seals lose all elasticity. Lubricants stiffen into wax. Everything relied upon to keep a spacecraft, or a human, alive must be entirely re-engineered against a thermal environment that is physically trying to freeze the mission solid. Any breach is not an emergency. It is a death sentence. It gives minutes, not hours. The atmosphere is not toxic like Venus, but it is not breathable. A human standing on Titan without a suit would not depressurize. They would suffocate slowly, in open air, while simultaneously freezing to death. A specific kind of death that engineering must design against. Not the swift catastrophe of vacuum, but a slower one that gives no warning and no easy reversal. Then there is the isolation. Titan sits between 2 and 5 billion kilometers from Earth. Radio signals travel at the speed of light. From Titan to Earth, that is between 68 and 84 minutes, one way. A round-trip exchange takes nearly 3 hours. Think carefully about what that means. A distress call reaches home in the time it takes to watch a feature film. Any decision that must be made in under 3 hours must be made completely alone. Any repair performed alone. Any medical emergency handled alone. If someone dies out there, we learn about it only after they are already gone. Apollo astronauts were 3 light seconds from mission control. The ISS crew today are milliseconds away. A Titan crew would be 84 minutes out. That is not simply a longer version of Apollo. It is an entirely different category of human exposure. It is isolation, with a mission patch. And this is the moon we're sending a nuclear-powered rotorcraft to next. Dragonfly is real. Not a concept, not a dream. It is a fully funded NASA mission currently in fabrication, with a launch locked in for July 2028, arrival at Titan set for 2034, and a staggering price tag of roughly $35 billion. That number ballooned from earlier estimates of around $1 billion. The mission is being assembled at the Applied Physics Laboratory at Johns Hopkins University. It's an octocopter. 8 rotors driven by a multi-mission radioisotope thermoelectric generator, an MMRTG, the exact same nuclear power source that keeps Curiosity and Perseverance alive on Mars. Titan receives so little sunlight that solar power is simply not an option. The nuclear engine isn't a preference. It's a survival requirement. Dragonfly will fly. That is the headline, and it is genuinely extraordinary. short hops of several kilometers between surface sites, analyzing chemistry at the Selk impact crater, where ancient liquid water may have once mingled with complex organic material. It is one of the most ambitious mission profiles NASA has ever dared to attempt. Every hour of that flight plan was optimized against Cassini-era atmospheric models, wind fields, temperature profiles, haze density, all derived from Cassini data and post-Cassini simulations. But then came Webb. Thicker haze, more aggressive chemistry, tropospheric weather nobody predicted, all of it landing during the mission's final build phase, when fundamental design changes are essentially off the table. Now consider what Dragonfly is not. It is not Ingenuity. Ingenuity flew in Mars' razor-thin atmosphere, less than 1% of Earth's density, with near real-time monitoring from engineers on the ground. Dragonfly flies through Titan's dense, crushing atmosphere under just 14% gravity in perpetual twilight on an 84-minute one-way communication delay inside weather models we now have serious reason to doubt. Every single flight is fully autonomous. Not because engineers prefer it that way, but because piloting a craft from Earth at that distance is physically impossible. Titan missions are rare. They take 6 to 7 years just to get there. Any failure at the destination cannot be fixed within a single career. There will not be a Dragonfly 2 in the 2040s. If this mission loses a rotor at the wrong altitude, the entire program of Titan surface exploration goes dark for a generation. The public framing calls it groundbreaking. That's true, but it's incomplete. What rarely gets emphasized is that this mission's core assumptions are being quietly rewritten by Webb in real time, during a phase when those assumptions can no longer be structurally changed. This is the mission being sold to us as safe. Read a NASA press release about Webb's Titan observations. Then read the actual scientific paper. Then compare them carefully. The press release uses phrases like unprecedented view, stunning imagery, confirms atmospheric activity. All true. All meticulously engineered. The paper describes methane cloud detections at specific latitudes and altitudes. It notes departures from expected seasonal behavior. It discusses methyl radical detection and its implications for photochemical modeling. It lists where observations agree with prior models, and where they don't, usually buried deep in the results section in dense technical language. Both documents are honest. Neither is complete. The press release is written for a congressional budget cycle. The paper is written for peer reviewers who already understand the fine print. But the gap between what scientists know and what the public hears is not a lie. It is institutional caution. Agencies survive on stable narratives. NASA is defending Dragonfly's budget through a period of intense federal pressure and competing flagship priorities. Any public statement emphasizing that new data is forcing a revision of Titan's atmospheric models in ways that could affect Dragonfly's core design assumptions would land in a congressional hearing within a week. So the press release says unprecedented view. It does not say our models were wrong in these specific, critical ways. This is not conspiracy. It is not corruption. It is the ordinary friction between science, which is slow and iterative, and politics, which needs clean, simple stories to keep the funding flowing. Every major scientific institution navigates this friction. And while it is generally managed well, managing it well is not the same as managing it transparently. The Cassini precedent matters enormously here. Cassini's most consequential findings, the vanishing magic islands, the unexplained persistence of methane, reached the public months, sometimes years, after they reached the science teams. Not because of malice, because working out what they actually meant took time. Webb is now in the early phase of that exact same cycle. The observations are in hand. The papers are being written. Meanwhile, public communications emphasize the beautiful images. The stranger, more unsettling implications move through the pipeline slowly, buried in language most people never read. Softer verbs where harder verbs would fit. Consistent with instead of requires revision to. Each choice defensible in isolation. Cumulatively, a distortion. Every world we have visited with a powerful new instrument has shocked us. Europa was thought to have a relatively thin ice shell. Better data suggested it is far thicker and far more geologically active. Enceladus was expected to be quiet and dead. Cassini caught it venting massive plumes of water vapor from a subsurface ocean that virtually nobody had firmly predicted. Pluto was assumed to be an ancient, cratered, frozen wasteland. New Horizons in 2015 revealed young surfaces and possible ongoing geology on a body that should have been completely frozen for billions of years. Io was known to be volcanic, and every single mission revised the estimates dramatically upward. Every one of these worlds was considered well understood, until we looked closer. Not most of them, Every single one. Titan is not an exception to this pattern. Titan eyes the pattern. The confidence we express in habitability rankings, in mission designs, in exoplanet analogies, is built on models that fail every single time a better instrument arrives. That is not a criticism of the scientists building those models. It is a description of the outer solar system, more active, more chemically complex, and more astonishing than the models keep predicting. Now widen that perspective. Every Earth-like world in a JWST atmospheric spectrum, every exoplanet whose atmosphere Webb is now sampling, is being interpreted through the very same class of models that Titan just embarrassed. If we cannot cleanly model a moon we have visited, orbited for 13 years, landed on, and now observed with the most powerful space telescope ever built, then our confidence in interpreting a planet we have only ever seen as a fraction of a single pixel is doing an enormous amount of completely unearned work. And the corrections always tend to run in the same direction. Bodies turn out more active than predicted. Atmospheres more chemically complex. Interiors more dynamic. Directional bias is a signal. It tells us our models have been systematically underestimating the activity of these alien worlds, probably because they were calibrated on Earth and the Moon, then stretched outward using assumptions that simply don't hold in radically different environments. We keep announcing understanding, and the universe keeps issuing corrections. Which means the real question Webb raised at Titan isn't about Titan at all. It's about how much of our supposed understanding of everywhere we haven't been rests on models that keep failing in exactly the same direction. Here's what Webb's Titan observations actually mean when you consolidate the findings. The chemistry is running faster than the models predicted. The atmosphere is more active than seasonal forecasts suggested. The methane source remains completely unexplained. The haze is optically thicker than the baseline. Dragonfly's design freeze is racing against incoming data revisions. The official messaging is systematically softer than the underlying science, and the pattern of shocking surprises at every outer body we've ever visited is not slowing down. Any one of those in isolation is a normal scientific development. All of them arriving together on the same target is a warning. Not fabricated, not conspiracy. A real, measured warning embedded in the papers, softened in the press releases, and largely invisible to a public that believes we already understand this moon. The Webb image that opened this video is still breathtaking, but read it carefully. It's also an indictment of how confident we were the day before it arrived. That is exactly how science is supposed to work. Better instrument, better data, revised model, sharper humility. What is not supposed to happen is the public arriving at that revised humility 3 years behind the specialists. To be precise about what this is not saying, Dragonfly should not be cancelled. It is one of the most scientifically valuable missions NASA has ever funded. Webb was absolutely right to look. The scientists are not dishonest, and the engineers are not incompetent. They are doing extraordinary work under genuinely brutal constraints. What this is saying is that the physical reality of Titan is harsher, stranger, and far less settled than the comfortable public framing suggests. And that gap is not being closed by press releases. It is being closed slowly, quietly, by papers most people will never read. Here is the narrow hope. The instruments are finally catching up to the questions. Webb is doing what no previous observation could. Dragonfly, when it flies, will produce ground truth data nothing else can deliver. Europa Clipper is already on its way. Enceladus mission concepts are advancing. The outer solar system is being investigated more seriously right now than at any point in human history. Catching up is worth something. It is worth a tremendous amount. But catching up is not the same as knowing. When Dragonfly reaches Titan in 2034, it will not find the moon described in the press releases of recent years. It will find the moon Webb has been quietly revealing. One methyl radical, one anomalous cloud, one thicker haze layer at a time. Whether the mission survives its encounter with that moon depends on how honestly we listen to what Webb is telling us right now, in the years when the design can still be understood against newer data, even if it can no longer be fully changed. Webb saw Titan for the first time, and what it saw should change everything about how we talk about what comes next. What it truly revealed was just how much we had been guessing all along. And that is the sentence NASA will never dare put on a poster.